So we have to start understanding Kubernetes because one of the toughest, one of the tools that is at the same time which is complex, but at the same time which is very challenging, and especially when we cannot help doing our automation and orchestration without a tool like Kubernetes, we have to learn it. Okay, that is why we have in our paid course as well, we have Kubernetes, 6 or 7 sessions of Kubernetes. We will learn Kubernetes is a big subject. Okay, and we cannot ignore, I mean, we cannot afford to not learn it. Kubernetes itself can take around almost like 1.5 months if I go into too much of details with so much. So Kubernetes has the potential to be one subject for a DevOps course. It is that vast and that very important. But in our paid training, what we cover is the most essentials and the most important part of Kubernetes, without which, even if we try to go to the greater details, it will not be able to end up. So let us carry on with the understanding. First of all, the question rises as to where Kubernetes fits in. Let me have, so when we say Kubernetes, it is in this position we see in the operate phase of the DevOps lifecycle. You know this lifecycle very well of DevOps. Starting from it is like DevOps lifecycle. It is like in a project you say ideation to implementation. In each phase of this software development life cycle, you can use for automation, you can use all these DevOps tools, okay, for each of these phases. And in the operate, after you have deployed your application code, you want to deploy it over Kubernetes orchestration, because there will be a lots of microservices as applications. And now for, say, there can be hundreds and thousands of microservices applications, small applications, which are independently running without having any loosely coupled applications. So for that to run in a very orchestrated manner, you need to implement Kubernetes in this stage. Along with Terraform, we have covered Ansible. We are now covering Kubernetes as well. And we have also covered Docker, because Kubernetes you need to have some containerization application. So it can be Docker being the most popular. It can be Mesos. It can be Rocket. But if you compare Mesos and Rocket, if you try to compare with Docker, they are minuscules. Okay, so we have learned Docker, we have learned Terraform, Ansible, and thereafter, so this in the operate phase, we provision, these are the DevOps tools. We will provision resources over the cloud, and we will then configure those provision resources using a configuration tool like Ansible, and here we will orchestrate. It is like orchestrate. It is like a huge band of orchestra, many musicians playing the band. Okay, and there is a maestro standing in the middle of hundreds of musicians. Somebody playing guitar, somebody playing your percussions, somebody playing on the flute, somebody playing on saxophone. So many instruments are there. Somebody playing on violin, piano. But there is this conductor who is guiding. So you can think of these musicians, individual musicians, as one and each and one every application. These are all applications. And who is driving who is getting this uh, entire thing working in a synchronized manner? This is this guy. This guy is Kubernetes. Kubernetes, KS, and there are 8 letters. One, two, three, sorry, R, 4, 5, 6, 7, 8. So it is called K8S. So this Kubernetes is the conductor of the entire show, of the entire orchestration of these microservices, the applications. And these applications these are called pods or containers by the name pods. Each of them are container, and each of the container, as we have learned in Docker, will have one what? Image. Image is nothing but an application. So those applications are microservices. It is an application in a loosely coupled. That means this application does not depend on this microservice, or this microservice does not depend on this microservice. So the entire thing is based on single applications running. Maybe they are interlinked or they are talking to each other, but all the health and everything of this will be maintained by the Kubernetes orchestration. You may ask me any question if you have. So before you you deploy it where? When you provision some infrastructure over the cloud, you configure that infrastructure on the cloud through Ansible, and then you will install and implement Kubernetes orchestration tool over to deploy the hundreds of microservices or your applications has given. Once you do that and they are stable, you go to the monitor phase. Okay, you go to the monitoring phase where basically this is the operations guys who will be using tools like Nagios, Splunk, Datadog. Okay, there is also Prometheus tool. All these are monitoring tools, but mostly being used by the operations guy. But it is not that you will not be using them, or as a DevOps guy, you should also learn at least one of this monitoring tool, or you can go for learning SRE, site reliability engineering, where you have the ELK stack. Now we are going to discuss that slide over here. ELK is the Elasticsearch. This is the entire thing is a stack. So Elasticsearch. This L is Logstash. This K is Kibana. So you have a graphical dashboard based on your Logstash and on your search. That means all these logs that are generated with, if there can be errors, defects, health issues, all these things will be reflected in the logs provided by the Logstash to the Elasticsearch. And through that search pattern, you can build your dashboard, graphical dashboard for your managers to have a view of what is happening on the production system. Is that clear? So that is a different subject altogether. Like the roadmap says, if you have learned DevOps, you should also learn SRE, or if you have learned DevOps, you should also learn DevSecOps, which is part of cybersecurity. Okay, DevSecOps. So we also have a plan to introduce SRE within our one more stream of learning training with Kalkey. We have not yet started this because uh, right now we are not getting enough number of students who would be interested. But in India, this branch has already started quite well. Okay. Anyway, that is a different discussion. Any question till now? You want me to continue or
Yes, sir.
okay?
Yes, sir.
Okay. Very good. Very good. So no problem. We will continue. So after this, let us go over to our roadmap, the DevOps journey. Okay. Unless and until we have completed our DevOps course, it will be very, very difficult to go into, yeah, in this advanced DevOps, but basically in our paid course, we cover lots of advanced topics in DevOps. It is not fundamentals. Let me erase this. This fundamentals, what we have mentioned over here, is not true. We cover a lot of advanced topics of DevOps. Okay. So after you have learned DevOps, you have completed this, we should encourage you or you should be motivated to this Kubernetes course is also included under this paid because earlier we thought we should make this a separate unit or separate module. But we found that many of the interviewers were interested in understanding whether the candidate knows about Kubernetes. So we have included this Kubernetes course within DevOps course as well. Here we have kept it separate, SRE, as we have said. But there is another path. Suppose you are not interested in learning SRE, you directly wanted to go this path, that is also fine. But you have to do this part. Otherwise, it will be quite difficult if you directly jump over to DevSecOps, which is a part of cybersecurity. It will take a lot of your effort to pick up the subjects because most of the time it is dealing with the security of the DevOps assets, okay, that we have created in this cycle, in this part. Most of the organizations are matured. They have already implemented DevOps. So the will the recruiters are looking for people who know DevOps pretty well, not a very fundamental thing. They have to know advanced bit of thing. Basically, they are looking for people who have done the project on DevOps projects. Okay. And if you are doing our paid course, you will be doing a capstone project. And this capstone project is coming with one more pipeline. We are now introducing, instead of GitLab, we are introducing from this course onwards, we are introducing Azure DevOps because it is much in demand nowadays, where you will get also some idea of Azure as a cloud. Though you have done the full knowledge gathering on AWS cloud. But it is good that you learn both of them, this in much more details than this, but yes, you will get some idea when you learn about Azure DevOps as a CI/CD pipeline. Okay, and we are going to do a project along with so many tools of DevOps, along with Kubernetes and Azure DevOps pipeline with Terraform, AWS CLI, Git, Docker, Docker Compose, and all sorts of tools, Terraform and Ansible. So entire project will be done. So once you have a great understanding of that project in our paid course, you will be able to, I mean, you will be able to attend any interviews based on your questions or understanding on all these DevOps tools. Once you do that, then you can now shift over to DevSecOps. Learning DevSecOps is very, very important nowadays because it is not only the DevOps, the tool, the assets of DevOps, you have to secure them. You have to secure your automated pipeline and the jobs and the applications that are running over onto the pipeline automatically. So this is one of the great roadmap. I will not go through it. It is already established fact. What are the top 5 skills in demand? Which is starting with Linux, Docker, Bash, Kubernetes, AWS. So this is a survey done by LinkedIn. It is not by Kalkey. Okay, and you see a DevOps engineer or an SRE have 21% in the demand when the highest one is development or engineering faculty who are in demand of 23%, followed by 21% of people who are knowledgeable on DevOps, including Kubernetes, including Linux, and of course, a cloud, which is AWS. So Kubernetes is designed by Google, and as you have seen, anything it is by Google. Okay, any software which has like the Android, like so many other applications, Kubernetes is one of the applications or software which is coming from the house of Google. So it is futuristic, innovative. See how many versions of Kubernetes till now in this very short cycle of Kubernetes in the history of Kubernetes, it is already version 30, starting from version 1. So there is a lot of upgrades and features added in this journey, the not very long journey, in a short journey of Kubernetes. Kubernetes is not even 10 years old, and a software in a IT industry which is uh, less than 15, 20 years is, you can say, it's a very in the very initial stage. And within this initial stage, it has covered almost 30 upgrades or feature upgradations or feature inclusions, 30 versions starting from 1 to 30. Okay, so that is the beauty of having a product from Google. And not only that, it is currently being maintained by the Cloud Native Computing Foundations. It is called CNF. CNF is a large organization or a body which sets the standards of a software. What are the requirements? What are the security restrictions and requirements? And all this, they are maintained by the cloud native. So aided by Google, product from Google having the stamp or endorsement from CNF is a big thing. There is an open source container orchestration system. Container orchestration because you are managing all the pods, all the containers within the system, within the cluster. Basically, Kubernetes is a cluster. There will be lots of nodes, more than one nodes, and there will be one master server in the cluster. So this is a Kubernetes cluster having all the network dependencies and networking inputs, pod networking, the various networks that are required to support this architecture. We are going to discuss that today. Any questions? If you have, please let me know. It is not a very simple subject, but it is also not very difficult as well. If you can understand it, it is very, very interesting if you can understand it. So the question is why the industry is adopting Kubernetes so fast? So fast. The first point is the instrumentality, deployments, and rollout management. That is one of the major features. It is called the blue-green deployment. Blue-green deployment. And that is we will learn it in details in our paid course, but then we will know that it can see this is a system which is running, okay? And you are not having any downtime. Let all the users which are connected to this system, they should not feel that the system is down. They are all connected through all over the world, from all over the world. Suddenly, it should not be taken out, okay? Because there are lots of business that is happening. But you cannot also say that there is a need for some feature upgradation. So there is some feature upgradation which is going to happen over here. On this is a production box, okay? And you are deploying it. So generally what we used to do is to make the system down. That is called a downtime. We will then, within that downtime window, we will deploy whatever the changes that we are supposed to do, all those feature upgradations and thing. And thereafter, we are going to put them, test it, and if everything is stable, then only we will make this up. After this, we will say it is uptime. We'll make this up. But the downtime window can range from 1 hour to 24 hours. It should not be more than that. And can you imagine if your main application is down for even 1 hour, what is the business loss? It's a huge business loss. Can you think your Amazon or the eBay site or your Microsoft is down for 1 hour? How much business is going to be lost all over the world? Your Google, your Android system is down. Google is down for 1 hour. Can you imagine? The entire world will come to stop, isn't it? So there is no way you can afford any downtime, not even for a minute. Not even for a minute. So what you have to do is to go for some technology which will support your instrumentality deployments and rollout management. If something happens see, this is running and gradually it is getting replaced by the other version. Gradually. It is called rolling out. And also if there is because you will do the testing all over into the production on the live system, which is a blue. Our intention is to change the blue to the green. So while you do the blue, the green one, the current green one, the system which is running is still running. You are gradually replacing it with the blue one, which is turning into a green. So you have upgraded version 1.0 to version 2.0 without having any downtime. Okay? That is because you have deployments. The manifest, you can deploy it with the manifest, the desire. It is called manifest files. Manifest files. Okay, you do that. You desire what you want to, and you can manifest that desire over into in the deployment manifest file. Resource bin packing. While you deploy, you can also, while you are doing the deployment, you can also specify the auto scaling part as well. So you will say that these are the minimum requirements of CPU and the memory for the containers. Basically, in the deployment, you are deploying the containers. You are creating the pods. Pods are nothing but the containers. You are deploying the pods. And during creation of the pods, you will specify what is the requirement of resources that will be consumed. Resources, CES, resources that will be consumed by the individual containers. If and when the pod will exhaust this thing, the CPU and the memory, there can be a horizontal or a vertical scaling. That will all be maintained by the Kubernetes orchestration tool. So automatically, you do not need to take care of this. You just have to mention what is the minimum amount of resources that is required for your pods to be done through the deployment manifest file. So because of this, you will come to the next phase, the next feature, which is the inbuilt service discovery and auto scaling. See, when you deploy hundreds and thousands of pods or containers or microservices, it becomes immensely immensely difficult to locate your particular application. You wanted to locate out of a jungle of pods. You want to go from outside. So let's say you are this guy. You are using a browser. This is a Kubernetes cluster. Okay, one of the application is running over here out of the hundreds and thousands of your pods. There are lots of pods in this. You wanted to access this, to discover this. So there should be a service discovery. You will know how to go about not get lost in the jungle and to reach this point. This is called the endpoint. You have to reach your endpoint. That is the application that you are looking for. And through some mechanism supported by Kubernetes, you will be finally reaching there with all security constraints and security hurdles. So you have to be authenticated. Your requests have to be authenticated and authorized, because these pods are very, very secured. You cannot access it directly at your will and wish. You have to follow a certain path. And all these things are determined by Kubernetes objects. It can work with the heterogeneous clusters as well. And because of this, you can do the auto scaling because you have already done the resource bin packing. So you can do automatic horizontal or vertical upscaling or downscaling. That will happen automatically. You can operate your cluster in a heterogeneous cloud, but that is too complicated. And if your organization is too big, you can go for having multiple clouds and your cluster scattered over multiple clouds. Any question? Persistent storage. When we learned about Docker, we have seen that the containers created by Docker, this is a container, okay? This is a container, and there will be an application within that container, which is called the image. Image within a container, making the container able to run that image. Okay. Now this container is ephemeral. What is ephemeral? We have discussed that. What is usually, what do you mean by ephemeral? It is temporary. It is temporary. It is temporary. So, if it is temporary, what will happen to the data created through this pod or through this container? What will happen to the data? What is the fate of the data? It is also temporary, ephemeral. But data is very important. Yeah, this pod can die. It can die. It can be destroyed. It can be deleted. But what about the data? We should be able to persist it permanently. So Docker produces a concept called volumes, Docker volumes, through which Docker can store the data produced from this container into the volumes. But those volumes are having a little bit of constraint, a feature constraint. It is not that vast. It does not have that many features or capability like the persistent storage of of Kubernetes. And that persistent storage is called PV and PVC. PV stands for persistent volume, and PVC is, this is PV, and the PVC is, anyone? Anyone? What is C? C is for claim. This is also an object like this. PV is an object of Kubernetes, and PVC is also an object. So you can persist your data over the object called PV, whereas to claim or to read or to store or whatever, so you have this object, another object called persistent volume claim. The combination of these two gives a solid foundation of storage within the Kubernetes cluster. It is like a persistent disk, like a hard disk. Their support for Amazon Net Services, East by South, Google Cloud Platform, persistent disk, and many more. Kubernetes includes support for persistent storage connected to homeless application containers. So basically, or temporary application containers. So this architecture is very, very important, provided by. So, and the other one is the high convenience option. Kubernetes is the production scale. Plant scale is the production scale. It basically that it means it works with large systems. That is what we want. Most of the organizations, whether it is a small organization or a medium organization or a large organization, they will require for future expansion, they will need some production class tool, enterprise level, okay, enterprise level. And that is provided by Kubernetes. Kubernetes is a plant scale. This needs special attention to high availability options. That means this production means the system should be available 24/7, all the 365 days. So can you imagine that your server should not be down for a single minute? It has to keep on running for all these parameters. So the thing which will be there, which is running that server or that system, should also be enterprise class, production class. It should be highly available. And options like multi-master, so you can have a cluster of single master and several nodes, or you can have multiple masters in the same cluster with nodes. So this is in one cluster. As it is, if you have a cluster of one master and several nodes, it's a powerful one. But remember, you are having two masters. So it is almost like 2 times that particular cluster. If you have 4 masters, it is 4 times the power. So it will support multi-master or cluster federation. So you can go for a federation of clusters. So basically, you are saying that I have a federation of 2 clusters. I have a federation of 2 clusters, one with 2 masters and another with 1 master. Okay, a federation of clusters. Cluster federation permits linking clusters. So these 2 clusters are linked up in this federation. And so that the containers, now this container or this particular node having several containers is also can be managed with this cluster. So if something happens with this cluster, if this cluster goes down, nothing will happen to these nodes or the containers within the node, because that will be taken over and taken care by the other cluster which is linked up. So the high availability option, so you will see your application is never down, highly available. Your cluster is very, very highly available. Okay, because here is your federation of clusters. So the containers will mechanically move to a different cluster if one cluster goes down. So let's say this cluster has gone down. Anything can happen. See, in IT, there is no perfection. Even a human being or no animal or no object in this world is perfect. There will be some blemish. Okay, so it can go down. If it is down, what will happen to all the running applications in the pods, in the various nodes? Don't worry. All these pods will migrate over to this available cluster, which is up and running. They will all migrate, move out to this cluster. Are you getting me? So this type of convenience options are available with Kubernetes to make it very, very highly available for any storming out to brave the storm. If something happens. Any question?
So does it mean that cluster is dormant, like it's up and running, but it's actually dormant until one fails?
No, it is not like somebody is dormant and somebody is sleeping. Okay, both are active. Both are active. But what happens? Both are running. This is running. This is also running. There are several, you have distributed your pods, your applications over 2 clusters. That's fine. This cluster is having 1 master and several nodes. This cluster is having 2 masters and several nodes. Okay. But suddenly something has happened. This cluster is down. That does not mean that this was sleeping. These have several other applications. They were running. But what will happen to these things will be automatically there will be a migration. That is how it is configured. Okay, you can do it with Kubernetes. And not only that, these 2 clusters can be in 2 different regions of the cloud. Let's say this cluster is in in Mumbai, and this is in Ohio. But they are forming sort of it's a hybrid cluster, uh, but they are linked up. They know each other because they are part of the same application or the same architecture infrastructure. Okay, so if the Mumbai cluster goes down, the all the applications which were running on the various nodes will migrate over to this Ohio automatically till the time this gets an auto recovery and brings up. So once it is brought up, automatically they will again be back to the old position. It will go back. Thus that the requests coming to this are not failing, because then it will be the request will be directed to this. This will be redirected. All the requests that were coming to this cluster will now be redirected to the Ohio cluster. This takes a lot of configuration things, but this will be supported by Kubernetes. Did I answer your question?
Yes, sir.
Okay, great. So I will remove this. Why Kubernetes have been adopted in this industry is in the industry of many organizations have adopted Kubernetes because of the 7 use cases. I will not go into details, but I will just highlight the one of this being simple app. So it is very simple to get your application up and running in minutes within no time because of Kubernetes services. You can make your applications deploy over a Kubernetes cluster very, very simply. And Kubernetes supports microservices, and the world has moved to applications which are microservice based. It is actually meant for Kubernetes is meant for microservices application, orchestrating complicated applications or apps based on microservice architecture. Microservice architecture has 12 rules to follow. You cannot say that this particular application is a microservice application. It has to pass all the 12 rules. Then only you say it is qualified as a microservice application. There are 12 rules. Okay? Whatever it will be supported over Kubernetes cluster. That is the big advantage. Lift and shift. Lift and shift is another technology which is like plug and play. Nowadays, everything is like plug and play. It becomes very simple to plug and play. You create some application and you just port it into or plug it into an existing application. This is, let's say, an application tool, and this is an application. You simply take it and plug it inside this application. It will start running. You don't have to do any configuration changes over into this application. So as it is, as if you are uh, putting something and fitting it into your already built application. It will start functioning from that moment. It is also the same thing, lift and shift, facilitating the moving of on-premise applications to the cloud. So your company has their own data centers where large servers will be there hosting applications. So you thought I'm spending a lot of money with capex and opex, capital expenditure and operational expenditure, but it was amounting to huge amount of expenditure, and every company is looking for cost cutting. You want to curtail the cost, everyone. Otherwise, how will your salary go up if the company cannot contain the cost, unnecessary cost? You are not going to grow, because the more cost effective your operations are, the more is your you will grow in that company, because you will get promoted, you will get hike in your salary, because whatever the cost cutting happened over here will be distributed to the employees. That's how it functions. So when you wanted to shift from your data centers to the cloud, you migrate to the cloud, you can use Kubernetes, helping, facilitating the movement from the on-premise to the cloud by using the lift and shift technology. You lift it from on-premise and shift it to the cloud. Got it? So this being one technology which is already provided with, this is Kubernetes. You are happy to, uh, you are very happy to use this technology, because it takes no time. Earlier, you do a migration, manual migration, it will take you months. Not only months, it will take a huge specialization effort from experts. And because they are experts, you have to spend a lot of money for the migration. Whereas nowadays, you use the technology of cloud and the technology of Kubernetes, and in combination, you can put your on-premise applications over onto the cloud in no time and with the least of effort. So spending a very, very less amount of money if you want to do that. Got it? And as I told you, this is supported by CNF. So Kubernetes is very, very solid, and it goes by the industry standard. Okay. It helps in AI-based, deploy the AI-based applications faster on a Kubernetes architecture, because uh, it can deploy the AI-based application, so you can bet on the heavy computing that is supported on a Kubernetes cluster, on a Kubernetes architecture. And of course, you can migrate, or you can deploy your entire CI/CD pipeline over onto Kubernetes. And that is the project that we are going to do in our capstone project, that we do in our DevOps, Azure DevOps. If this is an Azure DevOps, we will do, this is a pipeline. We will do our capstone project, where you will see that Terraform will build this cluster automatically through some scripts. Okay, and on that you will deploy the applications automatically. So we will do the CI/CD very nicely over a Kubernetes cluster automatically. So these are the 7 use cases because of which the industry has heavily adopted Kubernetes. Are you getting me? Any question? No, right? So can I move ahead?
I have a one question for you, Mr. Debashish.
Oh, you are back. So how are you,
Yeah,
Mr. Menon? You
I'm
were
I'm
working
doing
very, very late yesterday night.
yeah. So now why all of the job role we are right now facing in the job market, they require Kubernetes or AKS or EKS? Is it true that without Kubernetes is impossible to get a job in DevOps domain?
It is almost true, but it is not a myth, you see, uh, because your requirement of Kubernetes, it is like you have, as the world is moving towards uh, it was monolithic earlier. Okay. So what we observe is the stages, various stages. So we have migrated from monolithic architecture where it was hosted on a single server, a big server. The entire application, this is the entire application with smaller modules, but each of these modules are on very tightly coupled. So if anything happened to this feature or function or a module, then the entire application will get down unless and until this is up and running. You have corrected it. So it is a monolithic application. So it can be hosted on a single server. There is no need for a cluster or a network which supports a cluster. Now, now the world has moved up. You cannot help it. The industry cannot stay at one place. So the world has moved out to microservices. So loosely coupled applications, apps, or microservices. Microservices. Now to host these microservices, whereas see, this if you can separate it out, all single unit, and you can, as I told you, there are 12 rules. If you can change your function, each individual function, following the 12 rules, you have converted that thing into a microservice. There are lots of features, lots of criteria required to convert a module into a microservice because they are independent. They do not have any dependency on any other application or function, but at the same time, they can talk and seamlessly integrate with another microservice. So they can integrate seamlessly over another. So that is an architecture, but it's a very complicated, very complicated architecture. The question is very good. Actually, I am finding it very difficult to explain because it is automatically, it has migrated, and because people have come to understand the usefulness of microservices. Why? Because I do not want a downtime. That is the bottom line. If I do not want to have even a 1 minute of downtime, my system should be available not only 99%, it should be available 100%. If that means a lot, the difference of 1% means a lot to most of the companies. That difference makes whether the company is profitable, whether the company is doing a good business, or the company is moderate, and they can suffer losses at times. That 1% makes a huge difference. And to go for that, to cover up that 1% difference, we have to migrate from monolithic into microservice. But to host this, we need a solid and a robust architecture, orchestration, because this will all be captured within containers. This is, you can use virtualization, whereas to go for this, you have to go for containerization technology. So it is not that, it is because we have a course of Kubernetes and a Docker, therefore we are stressing this point. No, this is a requirement from the industry. Every other application is migrating from legacy or the monolithic into a microservice. So for to support this complicated architecture, you need a very complicated and a robust architecture itself, orchestration architecture, because to maintain the health of these numerous pods, say there can be hundreds and thousands of pods, or rather microservices, in a single application. Okay, that's a very complicated, and you cannot manually monitor which pod out of the 1,000 pod, which pod has gone wrong. It is absolutely impossible manually, or to develop a software which can take care of the health of each and individual pod and monitor real time what is happening, what is the health, whether the pod is able to cope with that with the load or the of the load of the requests that is coming in and accessing that application, whether it is capable enough or whether it needs an auto scaling, how automatically on the runtime it will understand. So it has given all this responsibility to this tool to manage this thing. So Kubernetes does 90% of those monitoring and the correction and the auto scaling and the auto replacement of the replicas. All these things are done by Kubernetes. You do not need to. You just have to implement it correctly. That's all. And you need to know the technology to deploy these microservices over onto the Kubernetes. So whether I like it or not, industry says that my applications are going to get transformed into a microservice-based application. So I would need a platform to host those microservices. And what is better than Kubernetes? So we cannot deny that need or the demand of the industry. Therefore, in our course, we have given a lot of importance to, because earlier, say almost 2 years back, we were not uh, we were not going through Kubernetes as a part of a module in our course. But because of the times, in the last 2 years, the demand, we have seen our students complaining that, okay, sir, we are going to interview, but they are asking most of the questions on Kubernetes because that is the trend. I am going to recruit you. I am giving a lot of salary to you, but you do not even know basic fundamentals of Kubernetes is not acceptable. So I will not be able to recruit you. That is the basic demand. We have to go by the industry demands, industry standards, industry requirement. And based on Kubernetes, there are many other tools which has come into operation like GitOps. Like GitOps is another stream of DevOps, but entirely based on Kubernetes. Then Argo CD. Because the more and more your company expands, as I told you, there can be not only restricted to a single master. It will be now 2 or 3 or 4 masters. So that means your company has expanded your application because the more and more customers are coming into the domain of that company in the realm of the company. So your company is facing a lot of architectural need to expand the platform. And also in an extreme case, when one cluster is not enough to handle the request, you are going for multiple clusters. And also,
Now,
if
will these multiple clusters be duplicates of the same?
sorry, again, is it Selassie?
Yeah. Will the second cluster be a duplicate of the first?
No. This is it is a unique one means in the requirement because that is a cluster. It is not that this has been replicated. No replication. You have built this cluster because you wanted to. The entire application is getting hosted onto 2 clusters. That is the need because your now there are initially when you started there were 10,000 customers. Now your expansion, you have expanded your business and now it is almost 10 million customers you have all over the world. So will that single cluster with one master be able to handle? Then you expanded it to 2 master, 3 master, 4 master, but still it is not being able to handle the requests or the load. To distribute the load, you created another unique cluster. It is not a replacement. It is a support. It complements. These are complementing each other. So if something request is hitting this cluster, and if Kubernetes finds that this request needs to be diverted to this cluster. It will do. It will do. You are asking, maybe your question was whether the applications hosted over here is also over here. Yes, that is a good question. Because if I need to redirect this request, I need to find that particular application. This application, let's say somebody is looking for this application, which is a pod, which is a container over here. Okay. This should also be available. The same application should be also available. This is a replica. You can say this is replica 1, replica 2 of the same application. So one request came, it got this application over this cluster. Fine. At the same time, another request came to access the same application, but Kubernetes found that the health of this is too much. This cluster is too busy. To give a better user experience of latency and all those stuff, so that there is no no lag of speed of access, speed of processing. You divert the and you means the Kubernetes will automatically divert. It knows with some mechanism that it has inbuilt. It knows that if I direct this request again onto the same pod in the same cluster, it may experience it can have a bad experience. So let us divert it over into the another cluster where the same application is there, so it will be directed over here. There will be a load balancer. There can be a load balancer from your Amazon or Azure, or you can build your own inbuilt load balancer to save the cost. Because as you hire the services of your cloud providers like AWS, Azure, the more and more, then there can be a more and more cost involved. So every lookout is to reduce this part, to bring it down, So to bring it down, we will also learn how to create our own load balancer without a single cent, free. That is why people are hiring you, because you know those technology. Okay. Mr. Menon, was that answered? Your question? Did I address your question correctly? Why there is a lot of importance for Kubernetes, learning Kubernetes? Because unless and until you learn Kubernetes well, you will never be able to migrate or to go and learn this technology called GitOps or Argo CD. Like there is the main industry. Let's say there is a car industry, industry which builds car. Okay, so you can say this is the Kubernetes. But there are ancillary industries. You are designing the car, you are the car manufacturers, but there are ancillary industries available to support the manufacturing of the car. Let's say this company produces the brakes. This company produces the gearbox. This company produces the steering. Okay. So all will now fit into building of this car. So this company is getting the procurement of gear or brakes or steering from this ancillary industry or the ancillary companies. But they are all contributing to the building of this car, right? So similarly, here is GitOps, Argo CD, and there are several other technology which will add up and build this Kubernetes cluster more and more strong with lots of other features. The main issue is the discovery of service. As more and more your applications grow in size and number, okay, you will find the best the hurdle. You will find the hurdle of finding your particular application. You have to go around the mesh of the services. It is called the service mesh. To handle the service mesh, how easily you can do that, you will learn GitOps or Argo CD. Otherwise, you have to do a lot of your manual manifestation, that is manifest files. You have to write a lot of scripts. If you are not using the help of GitOps or Argo CD, you will write yourself. Yes, you will get lots of salary because you are saving a lot of money for the company by not using GitOps or Argo CD. You are just, company has implemented Kubernetes and you are writing your own manifest files to enable the finding or to discover the service, to help discover the service or discover the endpoints, to reach the endpoints. How fast, because the performance is very important. You are searching for a particular service out of thousands of microservices, is the question of latency. But you can write a very good manifest file of how you can go about and find your particular application. If you cannot, then take the help of these tools. Did I answer your question? But these tools do not undermine the car company. These ancillary companies do not undermine the car company. Yes, you are learning GitOps. Yes, you are learning Argo CD. But that does not take away the potential and the necessity of Kubernetes.
Now, the reason behind, yesterday night, around late evening, we got 3 internal position, one on healthcare through a preferred vendor. So we
Yeah.
submitted the resume for Luis, Silasi, Tamzida, like 3 position for
Okay.
all of them 3. So
Okay.
they called us 3 times asking for if they have real Kubernetes experience or not. So I
Okay.
had a question to them that, hey, this is a cybersecurity position, like a DevSecOps, especially Azure. What
Yeah.
was the position I have shared? Azure security, and
Okay.
you are mentioning Azure security the with of 12%, 12 years of experience. For that, we have submitted Luis profile over there.
Okay.
But why you are like pointing Kubernetes, like focusing on particularly on Kubernetes? You should have a more uh, thing on security tools. So
Okay.
then he replied a very unique answer. So I have, this is a security position. So I know whatever people you are going to give, they have a security knowledge, a cyber security knowledge by default. The question
Okay.
is if they have the Kubernetes as extra or not, and that
Okay.
will going to decide uh, for the interview or not. So hopefully we'll
Exactly.
get an update from on Tuesday, but
Okay.
because Monday I think the job market will be a little bit close,
Yeah.
right?
Monday is the shift of power.
Yes. So Monday is the job market is closed. So Tuesday we will hopefully, if the position is still open, we'll get some updates because there's a paper vendor for there's 3 position, only 2 people have applied for all of from our like per position. So all of our these 3 people. So
Okay.
hopefully let's see if the Kubernetes is not creating any problem for them.
I believe they also know about Kubernetes. They have learned.
uh,
They have come to DevOps.
hmm.
Yes,
uh,
hopefully yes.
Mr. Debashish, I think why these organizations are really stemming on Kubernetes knowledge is because there is a lot of multi microservices that most of these organizations are into. Some of them are actually probably wanting to migrate to the cloud, okay? And they needed something that is solid, that can actually, carry all of whatever they have, because it's a large volume of data, okay? And also for the production organizations as well, they have multi-faceted, areas that they needed a very robust pipeline, CI/CD pipeline that can actually move all of these things. And of course, you did mention Argo CD, the other one, GitOps and OpenShift is also part of it as well.
OpenShift, yes.
That they are. So they needed people who has the knowledge of Kubernetes to move all of these things. And of course, Kubernetes being the fact that it's heavyweight, it's not lightweight like the rest of the other tools. So they believe that with all of this put together with Kubernetes, it will be easier and probably cost effective, to achieve this purpose. So that is why they are really stemming on the fact that Kubernetes you must have at least some kind of knowledge about
some
Kubernetes.
Kind of knowledge, if not in depth.
Yeah, Luis and
if they ask you to write a manifest file and there, it will be difficult. But you know what is how do you write a deployment file to deploy a pod over a cluster? So those basic idea. But if they directly, then it will become a very, very hard, difficult for any, even an expert in Kubernetes to ask him to sit and write down a deployment file immediately without the help of any of the tools or the ID, it will be very, very difficult.
It will be very difficult. Exactly. So if you mention to them that, okay, I've got knowledge of Argo CD, Harness, GitOps, that and that's what I'll be using, then probably that might see you through and don't have to go through the idea of writing a
manifest file. Yeah. Exactly. Yeah, Mr. Menon, you were saying something?
Yeah. So, Selassie and Luis, I have sent you one message yesterday night. Please reply me back with those all the documents in zip file as soon as you can.
Yeah. Can you send your email so that I can send it to?
Yeah, they need the documentation.
What'd you say?
Okay.
That they need the documents. I will call you. I'm not going to interrupt this class. I will call you separately.
Okay.
Yeah.
I'm here to receive it, sir.
Oh, okay.
Yeah. You send it to me now. Don't let us divide class.
I will go ahead. I will remove this diagram, this picture, and we can go to the next slide. So today, I will not spend more than another half an hour. What do you say, Mr. Menon? Because we still have one more session for Kubernetes to conclude. So I will just initially go to that pod level, and then we will conclude for the day.
Yeah, or else we can start from next weekend as well, because if it is a
yes.
Because we have today, or
let Mr. Trump take over, and we will also take over from the next session, isn't it? What do you say?
I think that will be a good idea.
Okay. So fine. With the permission of the class, we will start on the role of Kubernetes, and we will have to understand the architecture very nicely. So that you can understand the robustness of this architecture. So far, what I have said is only on the on the concept, on the concept. But now we will see through the architecture how this concept is implemented. Okay, the robustness, the availability, how it is ensured within the cluster. So therefore, I will stop at this point, uh, and we will continue from the next weekend.
One more thing, Selassie and Luis, I have added you our uh, yesterday's on like job ready classes DSA 43 because we have changed some of our course model. Instead of GitLab, we have introduced Azure DevOps. So I would like you to go through those things and prepare yourself for the upcoming jobs.
Okay, okay, sir.
Okay, any question, guys? Or because our cybersecurity free session is ended, we are planning to. We have a little dilemma. Either we are going to start a fresh cybersecurity from Fave, or we are going to squeeze our data science AI internship program for in these 4 weeks. Meanwhile, our DevOps, I think we do have one more session left. That will be next weekend, and then we'll take 2 weeks break, and then we're going to start a fresh one from I think February second week, the fresh batch. Our cybersecurity and DevOps job retraining has started yesterday, so that was a good start with a good batch. And there are so many students are very new on the IT field, and some of them here trying to switch from project manager, especially in Scrum Master. I don't know why people. I know, but still, there are so many people and students. They are trying to migrate from Scrum Master job role to DevOps or especially in cybersecurity. This Scrum Master, project manager, job, manual testing, QA is more or less going to end. Like not end, is going to evolve because of this AI. Right, Mr. Devashish?
Yeah, exactly. No, basically, what I also feel is the recruiters or the industry is looking for, even if it is a project manager management role, they are looking for technical project managers
Hmm,
who can talk about technology. So
true.
many people are who does not have to see. I have seen many project managers who does not have a little bit of knowledge on the technology. So they, in most of the meetings and in most of the discussions, they find very silent. They are very silent in those meetings because if you are not aware of the technology and the at least a little bit of overview of the technology, it is going to be a great hurdle. Many of the technical guys, many of the development guys, they are taking up the management role because today you are junior, but after 10 years you become a senior guy. So you will be promoted from your role, the development role, to a technical manager role or a technical functional lead or a tech lead. Okay, and also this thing. So it is always between the two project managers, one who is technical and the other one who is non-technical, but he's a good project manager. Project management wise, he has got a lot of experience and got a lot of things. But today, he finds it very difficult to compete with a guy coming from a technical background who has promoted himself as a project manager. It will be quite difficult to survive in the market. Many scrum masters, many project managers are now coming into technicalities to learn the tools. Uh, that is, I think, one of the requirements. That is the
Yes,
requirement
true, true.
most of the commitments are facing.
Okay, guys, if you have any question, feel free to ask, or else today we can close today's session. No question? Okay then. Thank you everyone. Have a great rest of your weekend. If you have any doubt or question, feel free to ask and ping us, Mr. Debashish, ping me, or we are happy to help.
Always, always.
Oh, okay.
So thank you for your time, gentlemen and ladies. Thank you very much.
Okay.